Hi. Good to see a full room. I'm Ashesh Badani. Here's Matt Hicks, Joe Fernandes. We've got a cast of characters. I'm assuming they'll introduce themselves.
Yeah, I'll introduce them as we go.
Do the demo. So thanks very much for coming. This is the OpenShift session. If you thought this was the OpenStack session, I'm glad you came. We'll talk a little bit about OpenStack, and then you'll feel like it's worth your time as well. Anyway, jokes aside, this is a session about OpenShift, our roadmap, and the evolution of platform as a service. You heard announcements from us yesterday. We'll cover some of those. But also the things that you heard today. If you attended the morning keynote, we talked a lot about innovation around containers and the Gear D project and where platform as a service is going from here on out. So with that, let me get started. We got a bunch of stuff going on. There's live polling for the folks who didn't catch it. Apparently, you've got to be pretty fast if you want to participate in the poll. We've got 3 demos going through, so we'll go through quickly. I'm supposed to be the opening act, which is just supposed to warm you guys up for the real stuff, so I'll kind of get through my stuff fast. OpenShift innovation. So according to the poll, and which seemed a little bit sort of fishy to me, seemed to indicate that a whole lot of you know about OpenShift. I'll assume that maybe not everyone got their answers in. We've been innovating on a very rapid pace. For the folks who don't know us as well, the technology came into being about 3 years ago with OpenShift Online, right, which is our public PaaS offering. That's received 15 service updates. Right? The entire platform's been updated 15 times with the applications running on it. And that's been a really great job by the engineering and operations team putting that in place. The OpenShift Origin is the upstream community project. That's where you have the opportunity to contribute or participate in an open community. If you're familiar with the Red Hat model, and you know Red Hat Enterprise Linux, this is analogous to Fedora, right? So there have been over 50 new features and enhancements in the overall OpenShift technology family, and those updates and enhancements all find their way into the upstream open source community, the public PaaS, and the OpenShift Enterprise private PaaS, right? So it's the same code base that's leveraged for that, and the Enterprise private PaaS has had 4 product releases in the past year. So across the board, whether you're participating in the upstream community or you're participating via the online public PaaS, which has been growing at a pretty rapid pace, and we'll talk some more about that, as well as adopting OpenShift Enterprise private PaaS, right? You're getting a really fast, continuous stream of innovation that's going on. With regard to the momentum, right? So let's kind of jump into that a little bit. We've got a session later today. There are multiple OpenShift sessions, but there's a specific customer session happening this afternoon. I'd encourage you to go check it out. We've got some of these customers speaking. But Cisco, FICO, PayPal, Boeing are all public references using OpenShift Enterprise in a variety of different ways. So I encourage you to go hear their stories and obviously go to our websites. We've got links around the videos, around their use cases to learn more about exactly what they're doing. And OpenShift Online's been on a tear. As I said, it's been in existence for just about 3 years or so. We add about 2,000 new users each week, right? So these are the folks who want to use the public platform as a service that bring applications. There's a huge diversity of applications, right? So if you go to OpenShift.com, you'll be able to see an application gallery, and you can go and see the diversity of applications from mobile applications, route optimization, to games that people have been creating with OpenShift Online. The user growth as well as the app growth has been phenomenal year on year. So about 150% and 200% for both user and app growth, right? So there's a lot of people getting into the platform and being able to create applications on it. And over 1.6 million applications have been created on the platform, right? Again, a great sign of the amount of adoption of the online public PaaS. And of course, there's recognition, right? So this is sort of the obligatory, we're in the Gartner quadrants, being recognized by, various awards, whether it be with the United States or, Asia, Developer Week, and so on. So just a great sign of validation, recognition of the technology and the progress we've made. One of the charts in there really talks about Red Hat OpenShift as compared both to public and private cloud platforms. And that's great to see because our strategy has always been one of hybrid, right? So of course an open source community, but a public as well as a private cloud leveraging the same technology and code base. And so we think there's a lot of benefit to be able to do that, and that's been reflected in some of the recognition we're getting. So let's now get into the heart of the conversation we want to have today, right? Which is we get a huge set of feature requests, right? Some of them by you in the room, and hopefully we're pretty responsive, at least giving you some feedback with regard to the roadmap and where we're going. But there's more features, right? Everyone always needs more features, right? Enhance it so I can use an external load balancer. Make sure that your logging gets better. Give me a better management framework with integration into an existing one that I have, and so on. Right? So functionality for developers, ops, and DevOps, right? Depending on the kind of role that you play. More apps, right? So got a huge Linux environment applications running there, but I also have Windows and .NET, right? What do you have to help support and enhance that? And then, of course, more choices, right? So there's a huge ecosystem out there of applications that are being built. How can you leverage that and make sure that I have as many as possible that can be used on the OpenShift platform, but also that's one that's easy to extend. So as a group, we're constantly sort of juggling across these. And I'm going to turn it over to Matt now to talk a little bit about kind of how we make some of those trade-offs and choices, and then walk you through some of the progress we made across all three of those.
Thanks, Ashesh. So I'm going to talk about more features for this. And this is actually, we've been doing this for about 3 years. And I think one of the most enjoyable things to me is the more people try to accomplish with OpenShift, the more we learn about their environments, what they need to do, different production scenarios, more complex apps. And that all boils down to specialized features, whether it's around deployments or teams or management. Now, but I always like to go back to like the first year that we talked. If our life was really simple, we started with one thing, and that was to make development easier. That's the thing that got us up every morning. That's the thing that we try to make OpenShift better. And I get asked that, like, what does OpenShift do? What do you try to accomplish with it? And this is it. And the other thing we sort of put as a subnote is we don't want to move operations backwards. So most of the people on OpenShift, we worked in IT for a long time, and we are very passionate about making development better and more capable, but at the same time, keeping operations sane as well. If you've been on PagerDuty or those things, it's an important aspect. You don't want to move one without the other. So over those last 3 years, we've been really busy, like down this route of features. We've gone from just having the online offering to moving that to commercial and having multiple commercial plans. Done over 50 releases. We have 40+ partners. So it's been an exciting 3 years for us of just every year seeing how things evolve in the market and how things change. But we also know, as much as I would love to say, like, well, we're done. We have everything you possibly need. We're not even close. The more that gets accomplished, the more people need, the more they see what they can do with the platform. But instead of talking to all those features, this is the first year I don't have to do the live demo. So I'm going to kick it over to Joe, and we'll actually have these guys show you some of the features we're doing.
Great. Actually, for just a second before we jump into the demo, we wanted to relate the roadmap. This is a roadmap session, but we thought the most effective way to do that was to show you what we've been working on and what we're going to be working on over the next few months. So rather than bore you with 50 slides and some beautiful roadmap charts, I've invited a few folks from our technical team to talk to you about what we're going to be doing. So first up is Grant Shipley, and Grant leads our developer evangelist team. So Grant travels around the country doing different developer events, and his teammates do the same. And Grant's going to talk about some of the most recent innovations that we've built on OpenShift that both our online and enterprise customers can take advantage of. So go ahead, Grant.
All right, thanks, Joe. For those that can't see me, I apologize if you've seen The Hobbit recently. Just envision Bilbo Baggins while I'm talking right here, all right? So I was asked to show some of the things that I'm most excited about, some new features that we have for OpenShift. And if you're not familiar with OpenShift, quickly what it is it's a platform to allow developers to quickly spin up new application runtimes to deploy code quickly. You can spin up a full JBoss EAP stack, for example, in 30 seconds. And it's great for systems administrators as well because it's a self-provisioning system, but the system administrators still have full control over the system to specify how much memory a gear can allocate and use, how much CPU. So they set it up and then it's self-service to developers. So I used to manage the sysadmins inside of Red Hat IT for production control, and what we would do is have a spreadsheet, and I'm sure most of you do this as well, with virtual machines that you allocate to developers, and you put their name beside it, and you track where they are. Well, with OpenShift, that is no longer the case. You can just have them self-provision. So one of the things I'm most excited about is the new cartridge API that we have to allow people to extend the platform. If we don't provide a runtime that you're wanting to run inside of your own data center, you can write your own cartridge to do that. So the application I'm showing on the screen is using the Vertex platform, which you may have heard about during the keynote. Vertex is a polyglot async runtime This application is consuming one gear. It's using both Python, Java, EE, or Java, as well as JavaScript to present this UI. This UI is actually a real-time flight tracker from United Airlines. If you pay attention, you'll see the little blue dots moving, but it's making REST API calls out to flight tracker. It's pulling in all the flight information, the altitude, the speed. So if I click on one, you can see the altitude of this flight's 3,900, so it must have just taken off, and it's going 570 miles an hour. And so you can click on, you can drill down into these, and did you just see them move? That was awesome, right? Maybe you can't see it on this, but they report their status every 10 seconds or something from I guess the black box inside of airplanes, and that information is publicly available, and you can create apps around that. So that's Vertex. They just moved again. I'm so proud of that. Right? So that's the first one that I'm super excited about is the cartridge extensibility. I've written Tomcat cartridges, for example, to take advantage of Tomcat 8 RC3 or whatever the latest version is. That's not quite made it into a production state yet, but I wanted to go ahead and play with it, but create a cartridge that's scalable and extensible so I can have a cluster of Tomcat machines, and I was able to do that with the OpenShift platform. The second one that I'm excited about is our new binary and deployment rollback mechanism, right? So as a developer or as a sysadmin team, you'll often push code out to production, and then you find a critical flaw or critical bug in the code, and you need to hot patch it or hot fix it or to roll those deployments back. I've seen people do a lot of different crazy things where they version RPMs and remove half the cluster, downgrade, and all kinds of crazy stuff. So we've baked that into the product now. So what I want to show you is another app. You probably don't want to look at my to-do list. Let me go over to my Chrome browser. And this is a similar interface to what we just saw with United Airlines, except for this interface, I'm tracking all the Major League Baseball stadiums in the United States. I'm a huge baseball fan. And so this little application, you can zoom in down to the city. This is Denver. You can look that this is the Rockies. It's Coors Field. The team payroll is $73 million, maybe, and they're in the National League. So this was our application, and we want to deploy a change out to it. So I'm going to show you the developer workflow of how they deploy changes. I am in my web application directory, which is MLB Parks. It's a Maven-based project, and so the index file is in the source main web app. So I'm going to VI the index, and I'm going to search for the text that was in the top right or top left, and I'm going to say MLB Stadiums at Summit, and I'm going to misspell it. And then I'm going to commit this change to my repository, and I'm going to push this code up to my production servers. And this takes a couple seconds to push the code up and to do the build. It's going to do a Maven build. OpenShift is aware of Maven build systems and dependencies, and by picking up that pom.xml file, it's building this remotely in the OpenShift server, which is in the public cloud at this point. And it's going to deploy that change out. And it should just take a second here. And this application is using EAP6 and Java EE with REST services. So I was able to make a change, push it out while we've been sitting here live. So let's go back to our browser here. And let me refresh this page. And we can see that indeed my change was pushed live. But I notice I have a critical bug. So what I do, right, I need to roll that back. So on the command line, I can say RHC deployment list, and it'll list all of the deployments that I have. I have a couple here. This one that I just made, what time is it? It's 1:38, so I deployed at 1:37. My last known good state was at 1:12, so about 20 minutes ago. So in order to roll this back, I'm just going to copy the command here so I don't have to type it. You basically type in RHC deployment activate and then specify the hash that you want to roll back to. I want to roll back to the one from 20 minutes ago. I'll press enter there, and it's going to pull that revision. And if this was a clustered EAP environment, it would update every node in the cluster. Okay? And rollbacks support every language inside of OpenShift. So now that was pretty quick. We rolled back. Let's see if it actually worked. You never know with live demos. Refresh the page, and sure enough, we rolled back our code to the last known good state in seconds, right? So it's very, very cool. The next one that I want to talk about is I talked with a lot of developers, and developers don't develop in silos. They work on teams. So they wanted some team development aspects to OpenShift. So I'm excited to show you guys what we have. I actually run a blog site for a mobile development site called tidev.io. OpenShift donates the hosting for that, but I didn't want to manage the code that's being pushed. And so if we look at the blog site, and I'll just pull it up here to show you the live site. This is the actual blog, if my network's working, that's running on OpenShift. This is the production servers here. But if you look over on the right, you can have members for a specific domain. So I've added Jason at bouncingfish.com and Matt, or Flock is his name, but he lives in the Netherlands. And they're administrators, so they control the code pushes, and I still have full access over it, but I'm not involved at all. I just let them manage anything. So why is this useful? One of the most common things we get asked about from developers and from sysadmin teams is how you promote code from environment to environment, from development to QA to stage to production. So what you can do is, as the system administrator, you can set up read-write access to your developers in the development domain, read access only to the QA staff to the development domain, but write access to the QA environment. I know this is a lot, so try to stay with me here. And then as a QA team, when you're ready to promote code to QA from development, because the QA staff has read access to development, but not write access, but both read and write to QA, they can simply type RHC app create, call the name QA build, pass in a new attribute that we have from application, and pass in the dev instance name. And OpenShift will go out to that dev instance that they have read access to, clone the source code, the database, everything, and promote it to the next environment. And then you can do the same thing for stage and production with limiting access control at each step. So those are the three most exciting things that we have going on from my perspective as a developer in OpenShift that's available today.
Cool. Well, thanks a lot, Grant. So Grant was obviously showing deployments from a source code perspective. Obviously, for developer environments, that's something that's very popular. We work across many languages, from Java to PHP, Python, Ruby, JavaScript with Node.js, and with Vert.x now. But as Grant was mentioning, when we go through the life cycle, if you get into your stage or prod environments, you may want to be pushing binaries and not source. So we also have a binary deployment interface. So if you want to actually push already compiled binaries because you're an administrator that's going to deal with production, we do that as well. So Git is the mechanism that we use for source code deployments, but we have a binary deployment interface as well. So Grant, you spent a lot of time talking to developers, all year long. What are some of the things that you're hearing from the developers at the meetups and hackathons that you've been going on in terms of what they like about OpenShift or platform as a service in general?
Well, it really depends on the developer audience. If I'm talking to Java developers, what they're most excited about is the plugins that we have available for most of the major IDEs, like Eclipse and IntelliJ, which is JetBrains is the company behind that. And because we have these plugins, they can provision their cloud servers, whether in the public cloud or in your private cloud in your own data center, provision their servers, push code, deploy, set up JBoss containers all from within their IDE with super fast speed, 30 seconds to do this type of stuff from inside of the IDE. For developers as a whole, what they're most excited about is they love developing software. They don't like messing around with downloading and installing the latest version of JBoss, hooking it up with Postgres, setting JNDI names, vacuuming tables in Postgres, applying security errata updates, things that they have to do in a development environment. So what they're excited about, they can spin this stuff up quickly and spend more time developing their code versus doing system administration tasks.
Cool. And you showed Vert.x, which is an exciting development upstream coming from our JBoss community. There's a lot of synergy between the JBoss middleware team and what we're doing in OpenShift. And we've exemplified this in our XPaaS initiative. What are some of the things coming out down the pike from the XPaaS perspective that you're most excited about, Grant?
For me personally, I was playing around with JBoss data virtualization last week, if I can say this right. And so I'm excited about that because with some of the stuff I do, like I showed you with the United Airline flights, I take a lot of different data sources and put them together. So I communicate with REST APIs, MongoDB, MySQL, Twitter, and create a mashup of all of this data. So with that product, you can actually create virtual, think of them as materialized views of data and combine all these disparate data sources together and run one SQL query, and it'll go out and collect all the information, cache it, and provide it to you instead of having to set up all of these different systems. And so that's really cool, and I'm using that in my projects now, and I'll continue to do so. And it's available on OpenShift today, which is where I use it.
Cool. All right, well, thanks a lot, Grant. I'm going to turn things back to Matt now. He's going to summarize some of the stuff that you just showed, and then we're going to move on to our next demo.
Great, thanks, guys. So we talked about this a little bit, and one of the things we were challenged in this is we showed you 3 features. We could have taken you through the whole hour, honestly, on new features. So we have the developer lounge that's there. These guys will be there the whole time. So if you see 3 features and you want to know what the other 12 or 20 or 30 are, go by and talk to them. I mean, each year that we come back, there's just tremendous evolution in the platform. Example of that is actually the PaaS offering. So I don't know, just a quick poll of hands. How many people saw the Middleware keynote by chance? Oh, okay, that's pretty cool. So PaaS, to me, is really platform as a service. It's always been pretty strong in the web application space. Web applications runs them well. If you're stateless, runs them even better. We have stateful capabilities there. But IT shops, a lot of times, they need a lot more than just web applications. They need enterprise middleware. They have integration needs. They have more mobile needs as they go on, business rules processing. PaaS for us has been about taking the entire JBoss middleware portfolio and making sure that runs on OpenShift. Cool part about this is you can actually go to openshift.com/XPaaS today and go launch and run all those products in OpenShift Online right now. So we won't demo all of those. There are other sessions I think I saw James back there. Yeah, some familiar faces of where there will be sessions. We'll go deeper into this. We're not going to do it in that session, but really, really cool stuff down here. But we are to live poll number 2. So this is your test, not ours. What are your organization's plans for PaaS? Oh, this is going to, okay, don't start the clock yet. I want to get everybody prepped. So get your phones. If you can get to the polling application, you're just going to see like 1 through 10 there. Get ready. You're going to have 15 seconds. I'll read these to you. So we're curious, option 1, you're already running a PaaS, whether it's ours or anybody else. Option 2, you're currently deploying it. Option 3, you're considering deploying in the next 12 months, and we'd love to know. Hopefully this session is going to move 12 months down to like 1 month. And then option 4 is none of the above. Hopefully we don't have a ton of people there. So get your phones ready, 15 seconds, and go in the back. That was good. We'll see if... And we got 2 more of these, so don't embarrass me up here. I have to introduce these other 2. If it comes back 100% 0, I'll know only one person answered.
All right.
Cool. So that's actually pretty close. I was surprised. I think it was in Craig's talk where he said out of our poll that 65% of companies are actually looking at utilizing a PaaS in this calendar year to do application development. And that's really what we're seeing in the market a lot as well. So hopefully we're going to go through 2 other areas, and we will, we're going to try to condense that. Hopefully you'll see great stuff here. So if we switch back to the slides, I will go, oh, I got it, Joe. I'll go into the second area, which is more applications. Now this is one, like, I might not like it. I'm a Linux guy, like that's what I'm growing up with, but we get it. Like we realize, companies don't want to have to choose between deploying a platform as a service and only getting it to run on their Linux apps, and then us saying like, well, you got .NET apps there, but go find something else to run .NET. Like that's a tough choice to make. If we can make you really efficient with application development on a Linux stack, why wouldn't we do the same thing on .NET if we could? And so in the same vein as this, we're just not going to put up some slideware and show you those things. We're actually going to try a live demo. So I'm going to kick it back to Joe and Vlad, and we'll actually show you what we have cooking with the .NET stuff.
All right, well, thanks a lot, Matt. So as Matt mentioned, we have had demand for folks who like what we're doing with OpenShift, but wish they could apply it to their entire application portfolio. And so we're obviously supporting Java today with both our Tomcat and JBoss cartridges. We're supporting multiple LAMP stack languages and Node.js on the JavaScript side and so forth. But there's that one gap around the .NET applications. So in true open source form, we worked upstream in the OpenShift origin community and with one of our partners, Uhuru Software. And I have Vlad here from Uhuru, and he's going to show you what Uhuru has built working with some of our upstream developers around how you can take an OpenShift environment and extend it to support .NET applications. So go ahead, Vlad.
Thank you, and hello, everyone. just having a bit of internet connectivity problems here, but
Only because
getting in there.
On my mobile phone,
Tethering, yeah.
and I took it out of the room, so it's my fault.
The beauty of a live demo.
So I'm going to start with Visual Studio, and I'm going to show you how you deploy an ASP.NET application using an OpenShift extension that we built. So we start with this simple ASP.NET app, and we set up deployment to OpenShift. And here you would connect to an OpenShift instance, whether it's Origin, Enterprise, or maybe in the future Online. You would connect to that. You would set an application name. You would select the cartridges that you want running there. So I have .NET here and SQL Server, domain that it's going to run in, and gear size. So we save all this, and then we're actually ready to deploy. So we right-click again, and we do deploy to OpenShift. What happens now is we manage security tokens for you. We manage SSH keys. We build the application if it's necessary. We package it all up. We upload it via SSH. And then we run a binary deployment remotely via SSH. So while all this is happening, I'm going to take you to the OpenShift web console and to an app that I already have deployed here. And you'll see that I have 3 cartridges for this particular app. The first one is .NET. This one lives on Windows, and this is where your application runs. Second one is a Microsoft SQL 2012 cartridge. This is where we're going to store some data and show it. And the third one is actually a load balancer, and this one runs on Linux. So this is a good example of how we brought the best of both worlds together, and you can take advantage of both Windows and Linux in the same application. So you can have one app that spans both Linux and Windows, which is pretty cool. So you can think about a .NET app that connects to MySQL or other Linux-based services. So now I'm going to move to the actual app that it's deployed. And it's up on an internal OpenShift deployment, simple ASP.NET app. And here we can interact with the database, some simple thing. We can record some data and display it. And we can see here information to connect to the database is the same, is available in the same way for .NET applications as it is for Linux applications. And to prove to everyone that this is actually running on Windows, I can actually SSH to the Windows box because we have Cygwin SSHD running there. So I'm going to list all my gears for the VS Demo app. And we're going to see 3 of them, and one of them is the .NET gear. And I'm just going to SSH to that. And we see here a Cygwin shell. And I can actually run the Windows command prompt. I can dir, and I can do this. So that's Windows Server 2012 R2 running there. And that's it from my side.
Cool.
Thank you.
All right, let's switch back to the slides real quick. So obviously, this has generated a lot of interest. When we announced some of this upstream work a few weeks ago, we've got a ton of questions from media, from customers. One of the most common questions I get is, wait a second, you guys aren't really running this stuff on Windows, right? You must be running it on Linux with something like Mono or Wine. And how's this actually running natively on Windows? So what I wanted to show was the architecture diagram, and then Vlad, maybe could you talk to folks about how you added a native Windows capability to the existing OpenShift platform?
Sure. So as you probably know, OpenShift has 2 components: the broker, which is kind of like the orchestrator of the PaaS, and then you have the node where your applications live. What we did is we created a new node from scratch. We implemented it in C#. We kept the communication layer, which for OpenShift is mcollective. And that mcollective agent will call .NET code in the backend. So it's a complete node written from scratch on Windows. And we've also implemented a security layer, Windows isolation project that helps with multi-tenancy in the Windows environment.
Yeah, that's great. So that way your .NET applications run where they're supposed to run on Windows servers. Your Java, your LAMP applications run on Linux servers, but it's common orchestration, common developer experience, common workflow for how you deploy these things. Yep. So what are some of the other new things that you guys are working on at Uhuru and with our upstream origin folks?
Yep. So we're working on a couple new things. One of them is Jenkins support. So you'll be able to build your .NET applications using Jenkins builds. And it's actually in a demoable state, so if you drop by the Uhuru booth in the partner section, we can show it to you. And the other thing is some administrative tooling for moving gears around Windows nodes, so essentially Windows districts.
Awesome. Well, thanks a lot, Vlad. I'm going to turn things back to Matt now, who's going to talk about how this is going to eventually come together into our online and enterprise offerings. Go ahead.
Thanks, guys. So where this is right now, and this is one of the great parts about having OpenShift Origin and actually working with the community there, is Vlad and the guys at Uhuru contributed this work to OpenShift Origin, and that's actually merged in. So now those capabilities are in the mainline code base in OpenShift Origin. So it's exciting. Go check it out there. If you have more questions, Uhuru has a booth in the partner area. We're at the PaaS booth and everything. Love to hear what you guys think about this as well. But as you might have guessed, we're going to do a poll first. Native .NET support from OpenShift makes my organization. A lot of people ask about it. What we'd like to know is, does that make you more likely to deploy OpenShift? 2, is it neutral? You don't care. You know, hopefully it's don't care. Like I'm on the Linux shop. I'm pure Linux. 3 is need to understand the solution better, to which I will answer, that's fantastic. Go chase those guys down. But get your live polling apps ready. And got 15 seconds. Why don't we go? Cool.
Yep.
Okay.
That's fair.
So that's great. So either of the cases, if you're neutral, don't care, that's fine. If you do want to know more about it, this is the time to catch the people that really know the details of this while you're here. So let's go ahead and flip back. We're going to shift now to the third area. So we might not be able to beat the Middleware team in that phenomenal demo, but we're going to try to beat them with breadth of demos that we're showing. So we're going to get into the third area here, which is, so we've talked about what are the features, what are those specialized features that we can get to make people be able to do more with the platform. We talked about more choice, so being able to leverage like .NET, Windows environments alongside under common management. And then this third thing is technology choice. Like I've learned, no matter how many cartridges we put out, there is going to be a new technology or a new version or something that somebody else wants and they want it now. And really getting that technology at your fingertips, so when you're building an application, you can pick and choose from the open source technology as well as commercial technology. That's really key. The challenge with this is the technical underpinnings to make this possible, they are always changing and evolving. You've seen a little bit about this, but let's talk about Linux containers first. So Linux containers, we call them gears. The reason we call them gears is that we started this work before Linux containers were really all that cool. We started about 3 years ago, and it was a really practical decision. It was like, look, we're going to run lots and lots, as in like hundreds and hundreds of thousands of applications, and I can't pay for a virtual machine to run every single one of those applications or components I'm on. And so it started as a really economical decision for us. If we're going to use Linux container technology, and for us, that was really kernel namespaces, SE Linux segmentation, Linux control groups, and being able to carve up virtual machines into these workloads. Now, we had to explain what the heck we were doing to people, and so that's where we came up with the term gears. If that was OpenShift's approach to doing secure Linux containers. Second part of this diagram that we talk about a lot is we'll refer to our nodes or those things. The node is really the operating system capabilities that we leverage to run those gears. So that's like your RHEL 6 host. That's where we actually get our security isolation from and our resource control. So let's talk about what's changing in this space, because this is really like, this is the year. Amazing things are happening in this year. First thing we'll talk about is the launch of Project Atomic. And Project Atomic is exciting to me because it is bringing an operating system instance that is tuned to run containers. that's like music to my ears, right? Because we build on that. And so now we're taking the next generation OS technology like systemd, like a new init system to be able to leverage that more, as well as an environment that's built to run things like Docker containers. And that's going to leverage that host, that node area a lot of what we're able to pull from the operating system itself. Now the second area, when we look at what our gears look like today and what we're looking at, there's a technology called Docker. Quick show of hands, how many people have heard of Docker before or used it? Yes, that's what we get a lot. And that is really key in that payload aspect of, great, anyone who knows Linux pretty well can launch a container. How do you launch a container and actually get your content packaged up and get in there? How do you get the choices of the 5,000, 10,000 different pieces of software you want running in a secure gear running on something like OpenShift? And so what we're doing is we are building the Docker technology into our gear, into our gears. We've launched a new project called GearD that's really going to be the union of the next generation operating system technology that you'll see come out of the Atomic stack, as well as the Docker technology to bring those two things together. This, we're hoping, is going to make my cartridge problem go away, because you're going to have the broadest ecosystem of software possible in the world, both the open source side from like Docker's index, as well as if you saw Red Hat did the announcement around our certified container program, which is going to bring RHEL's ISV base into a commercial container certification as well. So we think that really gives you that breadth of choice across whatever technology you want running in those gears. But this, I'm going to hand it back over to these guys, and we're actually going to show you all of this stuff running if the internet works with us.
All right, well, thanks a lot, Matt. So as Matt mentioned, gears or Linux containers have been at the heart of the OpenShift platform for day one. So those hundreds of thousands of applications that we're running, they're all running containerized across hundreds of Amazon instances, and we're making very efficient use of those instances. What GearD is how we're bringing gears together with Docker technology. So we're a little bit terrible at naming our products and projects, but that's what GearD is all about. It's the union of gears and Docker. And to show that off, we have lead engineer Clayton Coleman, one of the architects of our GearD solution. He's going to talk about how GearD comes together with Atomic and some of the components of OpenShift to build your application. So go ahead, Clayton.
Great, thanks, Joe. Can everybody hear me? So what you're seeing up on screen is a really simple demo application. So Grant was showing you an actual real application that did something. This is an application that's visualizing traffic coming into the application. So it's a pretty simple configuration, something a lot of people are probably familiar with. It's a load balancer, and there's 2 Java EAP application servers running this Java app. And then there's a back-end database. So every time I'm driving some traffic in the background here, every time a web request comes in, it gets recorded in Mongo. And then it's visualized here, so you can see this kind of steady flow of traffic against the application. So this is a demo we've done before. It's a visualizer. It's really handy to show the platform. But what's different this time is we're actually showing this built on top of systemd and Docker containers running on top of the Atomic base, the stuff Matt was talking about that integrates the operating system with Docker containers, and it's being set up and orchestrated by GearD. And adding these new technologies, as Matt said, a lot of new technologies have come in to the Linux kernel in the last 3 or 4 years. One of the ones we're most excited about is some of the networking capabilities. And today in PaaS, you're really limited because each individual component of a PaaS needs to go find all the other things it needs to talk to. And it's really been something that's bothered us for a long time, and we thought, well, instead of every component needing to talk to every other component, instead of everybody in the world having to go look up from a central server where these are, most of the platforms and technologies out there, like JBoss EAP and the Mod Cluster project, there's a lot of tools that are out there, technologies that allow enterprise application servers to talk to clusters, things that are now possible. And so we said well, let's build it so that we can put together a private container network, something that links all of these containers together so that the only thing they see is each other, and they don't need to know about all the complexities of the platform as a service. So I want to add some load here, and I'm going to start up a new EAP instance. So I had pre-created this, and I used the gear command to start up this container. So it was a container that was already created on the server. What you're seeing here are the logs of startup. And then we got to the bottom, and EAP is deploying the application. So it's a pretty standard startup process for an EAP application. And what will happen is, as soon as EAP starts up, it's going to talk to the load balancer, which it thinks is on the local host. It has no idea where it is in the cluster. It's just wired together using Gear D. It's going to talk to the load balancer and register itself. If I were to stop this, it would take it out of rotation. And so a lot of what we're trying to do is to bring these capabilities that already exist in the software out there in the world and make them possible in PaaS. So these kinds of virtualization of networking and process management, making it easier to build these applications together. So now that I've got this application running, I'm going to move to the next step, which is I have the EAP application, and I talked about it storing data in a database. Well, what it's storing data in is a MongoDB instance that we set up with our partners from MongoDB Inc. And this is a Docker file. So this is a Docker image, and a Docker image is a simple recipe that builds up a set of layers. So it builds the base operating system, all the libraries that you need. It moves into the application level, and then you do a little bit of configuration on top. So if you can see here on the screen, I'm pulling this from a RHEL 7 beta image. The Red Hat folks have been working on getting all of these images set up for Docker. And I just add the packages that I want to install, and these are the 10gen packages from upstream. So these are the packages that the MongoDB guys themselves support. And I'm just doing a little bit of configuration at the end. And this setup is going to be roughly the same across all of the MongoDB instances. But one of the things that's really powerful about Docker is being able to tweak it. So I can go in and I can use this image, and I can add my own configuration on it. So at the base, we're just talking about a simple development instance database, doesn't need to be tuned. But when I start moving into production workloads, I actually want to have a replica set. I want to take all of these Mongo instances and run them in a high availability setup. And one of those capabilities we talked about again, that private container networking is really important, because if anybody here has set up a MongoDB replica set, it's actually fairly difficult to get every little bit there correct. You need to have DNS names and ports. You need to make things sure things are properly exposed. And one of the challenges with that is that you're kind of fragile to the configuration of the underlying system. So what we're doing with Gear D is we're trying to make that simpler. We have these private container networks, and I just deployed a Mongo replica set. It's starting up in the background. And each of those containers thinks that it's running on a server, and it thinks it's talking to the other servers over localhost. But they're actually separate containers. They could be on a different data center. They could be on a different machine, on a different rack. It's just inside the container. You don't need to care about what's happening outside the container. The platform, the operating system is doing that for you. So at this point, I've started these 3 containers, and there's still a little bit of glue that I have to run to wire these together. But that glue is going to be exactly the same in every single environment I run this in because of that private networking. So if you see down here at the bottom, I've told it, oh, I want you to connect on this local address. And each of those local addresses is just a sequential one. The operating system is handling the details of making it look like each of these containers is on the same network. So Mongo's going to go set up. It's doing some stuff in the background. It'll take a few seconds. And each of those instances is going to talk to each other. And I shouldn't hit this too fast, because it's not quite that fast. So what's happened here is Mongo's come up. It was able to talk to those other servers. It's getting ping from them. And it's going through an initialization process. And I will run the command just to show you them all working in the background. Got a little antsy there. So the cluster is now in startup 2. That means that it's going through the process of doing the synchronization. And this will continue in the background. So you can see these are now in secondary status, and they're caught up. So I've set up a replica set. I can do that in a development environment. I can do that in a production environment. I can move these machines across cluster members. It's really about decoupling your application code and your services from actually where they need to be. The operating system and administrators can handle those details. So then to go back to the flow, we've had these 2 images, and we created the image. But it's not just about creating images, because as we all know from a frantic week last week, Heartbleed came out. Practically every bit of software on the internet had to go be updated, machines everywhere. It's really important to have a process that allows developers and engineers to be able to repeatedly build the software build their software and deploy it, to build it into images. And then when security updates come out, administrators need to go and rebuild those images as well. And every time you rebuild an image, if you don't have a process for rebuilding that image, then what can happen is you may not know what's going to happen. And so we've built some tools in the upstream OpenShift project. It's called Docker Sourced Images. And it's just one way of taking all of the different tools that exist in the Docker ecosystem and trying to give administrators and developers some best practices. So I ran an incremental build here, and this took all of the output that I had from a previous build, and then it took my source code changes and it ran an incremental build on top. And that's not something that you can do. It's not something you can do automatically in Docker today. But in OpenShift, we really believe that we want developers and administrators to kind of have a common process. So this is just one way of doing that. Now that I have that image, I've created a new image on my system that has my new updated code. I'm going to tell Gear to go replace the definition of the old container with this new image. And then I go ahead and do a restart on it. You'll see in the back end that this will be starting up. And I had made a change on that, but it's usually easier just to skip through to the end. So that's deploying and updating applications. And these tools, GearD is kind of focused at that lower end. It's to allow people to, from a single system or from a group of systems, to be able to easily go in and do this. I showed deploying a Mongo replica set, the containers that we showed before were deployed. Those kinds of simple tools for simple administration of containers. When you start talking about larger scale orchestration across tens of thousands of applications, that's where we start talking about OpenShift. And OpenShift, just like the applications that we were showing before, itself is a web application. It's a Ruby server that's handling the API and orchestration, talking to a MongoDB backend. So I have the images for OpenShift Broker and MongoDB already on my system. I'm going to tell Gear to deploy it. It did the same thing it did before. It wired those two together, and it's going to start up a broker. So this is an OpenShift Broker running in a container on my local system, managed by GearD. The system itself is linked together the same way. And once the server starts up, I can do a little bit of initialization on the system. So I'm going to tell OpenShift that I want to use that JBoss EAP image that I had before. That EAP image is going to get imported, and then I'm going to register this local system as an OpenShift node with this broker running on the system. When I do that, I'm going to use the RHC client tools. I'm going to connect to this local host, which I set up on a known port, 6060. I'm going to generate a token and all the standard stuff that any OpenShift client has to go do. So again, that was all running on that OpenShift instance that I had locally. And then I'm going to tell OpenShift to go ahead and create an app. And the app is created. And this is fast because because Docker and the tools that we're using are designed to be, the tools that we're using are designed to be fast, optimized for deployment. So we're building an image, and we're pushing that image out. Once the image is there, the kind of setup that needs to be done has already been done at the image building step. And so that image, OpenShift came up fast, MongoDB came up fast. There's a lot of speed and efficiency that can be gained because we know how to move bits around in networks pretty fast. But what we've had trouble with for a long time is getting those bits and then making sure that you have a repeatable, rerunnable environment across your cluster.
All right. Well, thanks a lot, Clayton. So hopefully what you guys have seen here and in other sessions is, Red Hat is heavily involved in Linux containers technology and working with communities like Docker to advance that technology. But what we're doing goes beyond just the container and deploying and running that container. What we're doing with projects like GearD and Atomic is making those containers work for developers, making sure that they can take source code that lives in Git, whether it's Java or Python or Ruby code, and deploy it to a containerized application and regenerate a new container with that code fully integrated, that they can wire together containers into a composite multi-container application, and that those containers can be spread across multiple hosts. So that's things for the developer. But then you also have the operator, right? Because in a private PaaS environment, we're not going to run OpenShift for you. Your operations team is going to run it, right? And so they wanted to make sure that they can have an optimized host environment for those containers. That's what Atomic's all about, that they can distribute those containers where it makes sense to run them on most efficiently across the compute instances where you want to run, whether they live all in the same data center or whether they're distributed across different data centers. So that's why we're doing things around networking, around Atomic hosts, and around some of the other things that Clayton mentioned and that we're working on in hand with our RHEL team and with the upstream communities. So Clayton, one of the questions I had is, a lot of this stuff is all about the core of OpenShift, the container technology that lives inside our hosts. How does the new GearD framework tie back into the rest of OpenShift, all the orchestration and other things that we do?
Sure. So what I showed up there was in a very early phase of OpenShift talking to GearD, but really the point is that the APIs, the client libraries, the client tools, and the REST APIs that OpenShift already exposes to end users doesn't need to change. The concepts are really compatible. There'll be new additions as we add the ability to add images and build cartridges on the fly based off of random image. But essentially, to an OpenShift administrator, to someone who has an existing deployment, these sorts of interface points don't change.
Yeah, so the idea here is that all the stuff that Grant showed in the first demo, where he's using either the command line interface or the web console or the Eclipse IDE to deploy applications and communicate through our broker, all that stuff will be brought forward onto the new GearD, the Gear plus Docker-based platform, and all that changes is sort of the evolution of the containers underneath and so forth. So we want to keep the same experience and so forth, and that's what we're working on now. But Clayton, before we do that, how can folks get involved today? If they're interested in Docker, if they're interested in what we're doing in GearD or Atomic, what are some of the ways that they can get started?
The first place to go, openshift.github.io/GearD. That's copied in a bunch of the press material you might see today. That's the open source community site. We've got the source code up there. We have packages for Fedora 1920, Rawhide. We also have EPEL 7 and EPEL 6 testing, although you don't have systemd on EPEL 6, so it's a little bit more difficult. We do have the source code up there, and we've been working kind of in the open. We would welcome contributions from the community and people who are interested in helping see the kind of tools that they're going to be using on RHEL 7 or on CentOS 7 or on Rawhide to manage containers and to manage their systems, to be able to participate in that and to give us your feedback.
Right, and if you also go to the Project Atomic community site, projectatomic.io, all the GearD stuff is integrated there. So, so really there's two different community sites at play. There's projectatomic.io, which is where a lot of the atomic host technology is being developed, and then there's GearD, which is just a subset of the Origin community at the Origin OpenShift GitHub location. You can find the GearD page there. And much like what we showed on the .NET side, the stuff that Vlad and Clayton talked about right now is not in the GA version of OpenShift Enterprise or OpenShift Online, but we are doing early access programs and talking to interested customers. So if you're interested in where we're going with PaaS for .NET, or if you're interested in where we're going in PaaS that fully integrates Docker and adds these new capabilities, just let us know. We're happy to take folks in, whether you want to work with us upstream or whether you want to work with us in sort of an early access on some of the soon-to-be GA product that we're putting out. So with that, I'm going to turn things back to Matt to do one more poll. Promise that'll be the last one, and then we'll conclude.
And I know we're down to like the 5-minute warning, so I'm going to go. We recap GearD pretty well. Broad ecosystem, great orchestration, sort of like where the DevOps movement. How much of these pieces you want to use is up to you, whether you want to use as an isolation or behind a fully automated PaaS. But we love Linux containers, but what we'd like to do is that quick poll of, we've been using them for 3 years, but for you guys, Linux containers are a key part of our application deployment strategy. Do you agree? Are you unsure? Need to know more? Or disagree? 15 seconds. Ready. Hit it.
Yeah, so if you want to go see these demos, at the booth, there'll actually be focused demos of each of these areas. So if you want to just learn about Mongo clustering on containers, or you want to learn about Atomic or GearD, you can go down.
Cool.
The containers pod will have the stuff I showed,
Yeah.
as well as the project Atomic work.
Yeah.
Yeah.
Right. Visit our partner booths, visit the Mongo booth, visit the Docker booth, and some of our other great partners that are contributing with us.
So it's fantastic. Hopefully that means we did not bore you to tears on the container stuff. Anyone who is unsure needs to know more, same thing. Like, you have the people here, learn these faces, go catch them in the developer lounge, those areas, and pepper them with questions. But let's switch back to the slides. We'll close it out and try to leave like 1 or 2 minutes for questions for you guys. But I mean, to recap, we just really see this as a combination of technologies for a better platform. We do think this is going to be the next generation of development. I've done development for a long time. I've done IT work for a long time. And this really does make both sides easier. Hopefully you sort of got a taste of what's in the platform today, as well as some of the things that are coming down in the roadmap, both on the Windows side and Docker and containers. So with that, give you like 2 minutes to either get to your next session or ask a quick question, and then we'll close it out.
And real quick, for those folks who came in late, we have some new O'Reilly books, some new OpenShift O'Reilly books. If anybody wants one, just come up at the end. We still got a handful.
We do not have
actually, forget about that.
Theoretically, they do exist here.
We may have more at the OpenShift booth. Forget I mentioned it. Okay. Does anybody have any quick questions before we break? Any?
You were talking about OpenStack.
Oh, sorry. Yeah. So for those who thought they were coming to the OpenStack session, so OpenShift is a platform as a service, but what you've seen is really it's a platform as a service that's built on RHEL. So basically, where you can run OpenShift is anywhere RHEL runs, and that includes OpenStack. So we have a lot of OpenShift enterprise customers doing deployments on OpenStack. You can deploy it on vSphere. You can deploy it on Rev. You can deploy it on Amazon like we do in Online or Google Compute. Any place where you can run certified RHEL hosts. Specific to what we're doing with OpenStack, we can talk to you more about it down in the booth. But because obviously we have investments in both sides, we're working on tighter integration so that OpenShift can take more advantage of some of the infrastructure services that are available at the IaaS layer. And so there we'll go beyond what we do for the other infrastructure providers to really improve the experience. And so that's some of the stuff that you can come down and talk to us about or talk to our OpenStack guys about. All right. Well, thanks a lot, everybody. Thank you.